recording now. All right, so a proof follows this form. You have some hypothesis, you go through deductive reasoning, and you arrive at the conclusion. What? Yeah, I'm basically just restarting the lesson because I'm doing it on video now. Okay. Hypothesis, deductive reasoning, conclusion. The real thing here that's the most important is the deductive reasoning. And the deductive reasoning consists of definitions, consists of postulates, it consists of properties, and it consists of theorems. Okay? Now, question is, what are all of these? Well, I'm going to give examples. Definitions, postulates. Okay. Well, a definition could be the definition, and I'll abbreviate it, the definition of congruent angles. You see? Definition of congruent angles. All right? Definition of congruent angles. Well, what does that definition tell us? If two angles are congruent, then what?
They're equal.
The measures are equal. So we can use that, right? If I say, how do you know that these two measures are equal? It's like, well, you told me they're congruent, and so I know they're equal because that's the definition of congruent angles, that their measurements are equal. Does that make sense? You see? Like an example of this, well, we'll go on. We'll get into examples. Or let's do it now. An example of this, I could say that angle A is congruent to angle B. And then from that, I can conclude that the measure of angle A is equal to the measure of angle B. You see that? I can come up with that conclusion. Does that make sense to you guys? And I can come up with that conclusion because that's the definition of congruent angles. If I tell you they're congruent, then their measures are equal. Why? Well, that's the definition of congruent angles. If the angles are congruent, then the measures are equal. Does that make sense to you? Anybody with me? Yeah? Okay. All right. Then the next is a postulate. You know what? I'm going to actually organize this in a better way. Okay, so let me organize it in a better way so you guys can see it visually. You can just start on a new page if you want or whatever. I'm sorry. All right. Or you can just keep what you got. It's up to you. Okay, I just think it's better if I just write it in a table. How about this? Okay. So the definitions, give an example what it is. Hold on. What it is. All right. So let me just. All right. So the definition, for instance, an example would be the definition of congruent angles. And an example of that would be like, we know that the definition of congruent angles means the measures are equal, right? That's what it tells us. And an example of this is if I say angle A is congruent to angle B, then the measure of angle A is equal to the measure of angle B. Can you guys see that now a little bit more clearly? You understand the information I'm presenting to you a little bit better here, maybe? Okay. Well, what's a postulate? A postulate could be the segment addition postulate. Okay. And what does the segment addition postulate say? Well, the segment addition postulate says if I have this segment A, B, and I put point C in between them, then I know that AC plus CB equals AB. And so what I could get from that, is exactly that. Segment AC plus segment CB equals segment AB. You understand? And how did I know that? Well, I know that based on the segment addition postulate. Can you kind of see that? CB. Now, properties. Properties could be like the addition property of equality, right? And what does the addition property of equality say? It says that I can add the same thing to both sides, right? That's what the addition property of equality says. Well, and what this could mean is if I have A equals B, right? Or let me make it more clear. If I have like x minus 1 equals 2, then I can add 1 to both sides and I get x equals 3. You see? That's what the addition property of equality says. And how do I know that I can do that? Because of the addition property of equality. Okay? And an example of a theorem would be the linear pair theorem. And what this tells us is if two angles are linear pairs, then they are supplementary. If two angles are linear pairs, then they are supplementary. And what could this say? Is if I say angle A or angle C and angle D are linear pairs, then the measurement, then angle C and angle D are supplementary. That makes sense? You guys understand that? Two angles, sorry, not zangles. Two angles are linear pairs, then they are supplementary. If two angles are linear pairs, then they are supplementary. Okay? So these are all tools that we need to have in our toolbox. We know the definition of congruent angles. We know the segment addition postulate. We know the addition property of equality. We know the linear pair theorem. There are other definitions, postulates, properties, and theorems that we know. Those are in our toolbox based on the lessons that we've already gone through. We have to be able to use them. And we have to be able to use them because we need them. We need those tools to do our deductive reasoning, to come up with our conclusion in our geometric proof. Okay? So, that's the whole idea. Okay? That's the whole idea here. Now, the question is, how do we apply these? All right? Sorry. Just give me 1 second, and I will get back there. The question is, how do we apply these? Okay? So this is how I would apply a definition. This is how I'd apply a postulate. This is how I apply a property. This is how I apply a theorem. You can kind of see these different things that we can come up with. But how do I apply these in an actual problem? That's the real question. Okay? Yes, just give me 1 second. So how do I apply these in an actual problem? That's the real question. All right, guys, I really got to move forward. So remember, this is going to be on YouTube, so you can always check on my CCA. All right. So let's take a look. At one of our resources here. So the worksheet that I just handed out to you says reteach on the top. And it kind of marches you through a question. So let's take a look first. Yes, sir? You guys didn't get one? Anyone else not get one? All right. So now here's the deal, guys. Okay? One thing about geometry class is it's not algebra. Algebra 1 is assumed that you guys are going to just know Algebra 1, okay? But it's not, this isn't algebra. And this isn't just squares and rectangles and triangles and using numbers and math. Geometry, a lot of geometry is stuff like this, where we're learning how to understand geometric shapes and lines and rays and points and things like that. So if this kind of thing is confusing you, you got to start looking at what the core is here. And the core is understanding what the question is asking you for. Okay? And it's a lot of language in this class. And I know sometimes word problems can be the hardest. And so sometimes we can struggle with language. And that's understandable. But if we're struggling with language, we have to develop techniques, whether it's highlighting or whatever it is, to be able to move ourselves forward. So let's take a look at this. So here's our question right here, okay? And I'm just going to separate it out. From everything else. And I'm going to bring it in here to my little notepad. So this is this given thing here. You see that? You guys see this? This is what we're focusing on. Okay, so gives, here's our picture first. Then it says BD, and that's a ray, is the angle bisector of ABC. So I'm going to highlight that in red. BD is the angle bisector of angle ABC. So here's angle ABC. Well, what do I know then about these two angles? ABD and DBC. If this is the angle bisector, what do I know about these two angles? Reese. Yeah. So this angle is congruent to this angle. Okay? Now, and ABD is congruent to angle 1. So ABD, you see this, is congruent to this angle. That's both given. All right? And what they want us to prove is that angle DBC is congruent to angle 1. So they want us to prove that this angle DBC is also congruent to angle 1. You see that? Does that make sense to you guys? You understand that? Okay. And so this is what the proof is. The proof starts with what we're given, and then it moves forward based on what we know. So the first thing is that BD is the angle bisector of angle ABC. Okay? That's given. So this is a 2-column proof. Here on the left, I have the statements. These are the statements. And these are the reasons. Okay? On the left are the statements, on the right are the reasons. So the first thing is BD is the angle bisector of ABC. Okay? And that's given. Now, the next thing is I know that angle ABD is congruent to angle DBC. Why? Because that's the definition of angle bisector. All right, let me try explaining this in a different way. How do I know that those two angles are congruent? How do I know that these two angles are congruent? Because this is what? That's the bisector, right? So I know that these two angles are congruent, right? Right? And then it says, it gives me that this angle ABD is congruent to angle 1, right? It gives me that. Well, if this angle is congruent to this angle, and this angle is congruent to this angle, well, then they're all the same exact measure, right? So therefore, this angle must be equal to that angle. You see? Does that make sense to you guys? You understand? So there is the plain words proof. I just proved it to you in plain words. But the thing is in this class, we're not just going to say, oh, well, I know this and this and this. We're going to formalize it. And to formalize it, we have to go through a proof. All right? And so we march through our proof and we say, okay, well, I don't know what my next step is going to be, but I know the first step is to just state what I've been given. So I've been given that BD is the angle bisector of ABC. I always start with something that's given. Okay, so I start with that. And then what's the reason why I know that? Well, because it's given. And then, well, if BD is the angle bisector of ABC, well, what do I know about those two angles?
They're complementary.
Supplementary. They're congruent. So therefore, I know ABD is congruent to DBC. So it's a logical, keyword, logical next step to say that ABD is congruent to DBC, you see? It's logical to say, well, if that's the angle bisector, then the next step is to say, well, those two angles are congruent. Does that make sense? Okay. And how do I know that those two angles are congruent? That's the definition of an angle bisector. If this is the angle bisector, well, the definition of an angle bisector is it splits an angle into two congruent angles. Splits it in half, right? Or it splits it into two congruent angles. You see? Does that make sense? Okay. Well, there I just came to something. I don't know exactly what I'm going to do with that, but now I can say, well, I also was given this, right? So I write that down. ABD is congruent to angle 1. ABD is congruent to angle 1, you see? And how do I know that? Because it's given. All right, well, wait a second. If I know ABD is congruent to angle ABC, and I know ABD is congruent to angle 1, then what do I know about angle DBC and angle 1? They're congruent. And how do I know that? The transitive, you guys remember that? The transitive property of congruence. If this is congruent to this, and this, if this is congruent to this, and this is congruent to this, then I can cut out that middle one and say directly DBC is congruent to angle 1. You understand? Instead of having this and this, I just cut that out and I say directly DBC is congruent to angle 1. That's what the transitive property does.
Transitive property just means it to flip, right?
What?
Transitive means to flip.
No. That's the reflexive property. Transitive property, class, remember the transitive property says, like, if A is equal to B and B is equal to C, then A is equal to C. Remember that? And that's basically what we have here. This angle is congruent to DBC, and that same angle is congruent to angle 1. Therefore, DBC is congruent to angle 1. Does that make sense to you guys? A little bit? So you see how we have to understand what the transitive property is. Guys, hear me out, okay? If this is confusing you, right? How many of you guys watched the video before you came here today? 1. Okay? Right? Okay, we got to take responsibility. If we want to succeed in this class, we got to take responsibility. The first time you guys are seeing this is right now. That's the exact opposite of what I have intended for you guys. Alright? I'm marching this forward class depending upon the fact that you're watching those videos. If you're not watching those videos, then guess what? The first time you're seeing it is in class. Now I'm clearing out all the confusion because you've never seen it before and teaching at the same time. It's not that we're not going to be successful if that's the way it is. You guys have to watch the videos. You have the resources. They're right at your fingertips. It's just a click and maybe 20 minutes before class. You have to watch the videos. Because otherwise, we're just going to be going through these lessons. It's going to take us way longer every single day. Okay? So, that was our conclusion. The whole thing we're trying to prove is that angle DBC is congruent to angle 1. Bam. Yes, sir? No. So angle DBC is congruent to angle 1. So that's our last thing because we proved it. You see? That's the whole thing we were trying to prove. Now, the next thing is it gives us this opportunity to do the same thing. Okay? So, this it doesn't just tell us everything, it's asking us to give the reasons. You see? On the left of a two-column proof is the statements. So here are the statements, and then we need the reasons. So let's go through this pretty quick because I want us to get to the next one. Okay, N is the midpoint of MP. Okay? N is the midpoint of MP. So here's N is the midpoint of MP, that's this right here. Q is the midpoint of RP. So Q is the midpoint of RP. And PQ is congruent to NM. So PQ is congruent to NM. We know those two lines are congruent. You see that? Is that clear? All right. So the first statement is N is the midpoint of MP. What's the reason for that statement? It's given. Okay. The next statement is Q is the midpoint of RP. Again, it's given. Okay, so you should be filling it out with me. Then it says Pn is congruent to Nm. Well, here's Pn and here's Nm. How do I know that those two line segments are congruent? What was that? Because N is the midpoint. We know that those two line segments are congruent because that's the definition of a midpoint. The definition of a midpoint says it splits a line segment into two congruent line segments. Okay. The next one is PQ is congruent to NM. How do I know that?
Given.
It's given. Exactly. Good. And now number 5 says Pn is congruent to PQ. Well, how do I know that? Pn is congruent. Yes? Transitive. Good. Look, Pn is congruent to Nm, and PQ is congruent to Nm. So look, they're both congruent to Nm, Pn and PQ. Therefore, I know Pn is congruent to PQ, and I know that based on the transitive property of equality. You see that, guys? Okay, good. Then it says,
Congruent instead of equality.
of congruence. Thank you, sir. Thank you. POC.
POC.
Transitive property of congruence, because it's congruence, not equality. Thank you, sir. Now, PQ is congruent to QR. Well, how do I know that PQ is congruent to QR? Definition of a midpoint. Very good. Q is the midpoint, so I know these two line segments are congruent. That's the definition of a midpoint. And then the last is Pn is congruent to QR. Well, no, that's not given. That's transitive. Well, let's take a look here. Let's take a look. We know here's PQ. No, that's a prove. We know that the prove should be always the last step, you see? Prove is always the last step. The thing in the proof that I'm asking to prove is always the last step. Once I'm there, I'm done, right? So, no, but you don't say just proof like that. Look, PQ and PQ, Pn is congruent to PQ, and QR is congruent to PQ. Well, how do I know Pn is congruent to QR?
Isn't it the
Transitive. We have to be able to recognize when we need to use that property of congruence. You see that, guys? Is that a little bit more clear now?
Yeah.
Okay. Now, so that was reteach. Now, flip to the back. Okay, and you're given another example. Any questions on this one? Okay, now you're given another example, and we're not going to go through that. We're going to go right to the one that we are going to do together. You can look at that example as another resource for you. Okay, fill in the blanks to complete the two-column proof on the right angle congruence theorem. Okay. You're given that angle 1 and angle 2 are right angles. And it says prove that angle 1 is congruent to angle 2. Okay, well they're obviously congruent. They're both 90 degrees, they're congruent. But we have to prove it. Okay, so it says it's giving statements and reasons and some are blank. Well, the first reason is given. Well, what should go here for my first statement? Angle 1 and angle 2 are right angles. Right? It's the only thing that's given. I should never think that something else is given. I just literally copy whatever it says is given. Does that make sense? Okay. And then it says, hey, the measure of angle 1 is 90 degrees. Well, how do I know? What's the reason? It's not given.
Or the definition of a right angle.
That's the definition of a right angle. What's a right angle? If I tell you I've got a right angle, what's the degree measurement of that angle? 90. Why? Because that's the definition of a right angle. Okay. Then the next one, it says the reason is the definition of a right angle, but I'm not given the statement. Well, what's the only other statement I can make? That's the
Angle 2 is a right angle.
Look. I know that angle 1 is 90 degrees, but what else do I know about, what do I know about angle 2? It's also 90 degrees, and how do I know that? That's the definition. So that's your clue there of what this step should be. You understand? The clue of what this step should be is that it tells me I'm using the definition of a right angle. Well, there's only one other right angle. It's angle 2. So I got to be talking about angle 2, and I have to say to you, well, hey, the measurement of angle 2 is equal to 90 degrees. Okay? You understand that? Okay. Now, I have measure of angle 1 is 90 degrees. I have the measure of angle 2 is 90 degrees. And then the next statement is that the measure of angle 1 equals the measure of angle 2. What's the reason?
What's the definition of equality? Not equality. Transitive.
We're using this transitive property. Look, they're both equal to 90 degrees. That means they both must be equal. If this is equal to 90 degrees and this is equal to 90.
It would be polar.
Is that an equal sign or congruent? Oh, the transitive property of equality. You see, we're using this quite often.
Transitive means equal.
Transitive doesn't mean equal. Transitive specifically means I have this is equal to 90 and this is equal to 90. Well, if they're both equal to 90, then they both must be equal to each other. Okay. The transitive property would be like if A equals B and C equals B, then A must equal C, right? That's what the transitive property tells us. And that's exactly what this A equals B and C equals B, then A equals C. You see? Okay. Now the last thing, first off, what's the last statement always in every proof? The proof. I don't have to think. Angle 1 is congruent to angle 2. And I'm done here. But wait, definition of congruent angles. Why is that the reason? How did I know that? Well, what is the earlier step? The measure of angle 1 equals the measure of angle 2. How do I know that angle 1 is congruent to angle 2? Yeah. Their measures are equal. That's the definition of congruent angles. Does that make sense to you guys?
Yeah.
You kind of getting the hang of this? You understanding a little bit? Okay. So that was the reteach worksheet.
So the definition of congruent is equal to, right?
Congruent is the measures are equal, okay? Or the lengths are equal. Congruent is basically how we talk about shapes being equal. All right? Now listen, not quite yet. Okay. Now, this is actually the worksheet. That was just a precursor to the lesson. This is the same exact lesson, but this is actually what your homework is. Okay?
What side?
We're going to start it, so practice A and practice B are your homework. Okay? But this is exactly what we've already been covering today. Okay? So if we go ahead and look at practice A, we're going to try and get through that before the bell rings, or at least make considerable progress. All right. By the way, class, these kinds of things are exactly like what your test is. So if by being able to do this, you're going to be able to do well on the test, which is on Monday. Tuesday, sorry. Sorry. What? Okay. When are you going to take it?
I can't do it today because your hours.
Okay. Well, you can do it tomorrow. Yes, sir? Can you say number 1? Yes, but first I want to go through it so we all are on the same page. Okay. It says, write the letter of the correct justification next to each step. Use one justification twice. Okay, so it's given that HJ is the bisector of IHK. So HJ is the bisector of IHK, and angle 1 is congruent to angle 3. And it says, okay, so the first thing, okay, so it doesn't ask what to prove, which is interesting, but the first thing is HJ is the bisector of IHK. We have these reasons over here on the right, A, B, and C. So it's given. Yep, given. Simple as that.
It can only be used once.
No, it says use one justification twice. Okay. Now it says angle 2 is congruent to angle 1. No. A. That's the definition of an angle bisector. If it's bisecting the angle, then the two angles must be congruent. The third one is angle 1 is congruent to angle 3.
B.
That's given as well. What?
Alright.
You understand?
Yeah.
Okay. Then the next one is angle 2 is congruent to angle 3. How do I know that?
Because it's bisects.
The transitive property of congruence. Look, 2 is congruent to 1, and 1 is congruent to 3. Therefore, 2 is congruent to 3 based on the transitive property. Okay? And then number 5, in a blank proof, each step in the step is on the left and the reason for the step is on the right. What you fill in here is in a 2-column. In a 2-column proof. Okay? You guys understand that? Okay. Gotta be with me. I understand. You got a test after lunch or something?
Oh no, I wasn't doing it. I was just going on CCA.
Okay. I know, but just stay with me. Okay. All right. Guys, we shouldn't even have our computers like out unless I ask you to pull them out. Okay. All right. Let's go on to the next one. Okay. All right. Fill in the blanks with the justifications and steps listed to complete the two-column proof. Use this list to complete the proof. Okay, so it gives us a list of things to fill in the blanks with. You see? It's this thing here, and this thing here. It says given angle 1 and angle 2 are straight angles. Okay, straight means they just make up a straight line. It says prove that angle 1 is congruent to angle 2. Well, the first thing is given. Well, what's the only thing that's given?
Angle 1 and angle 2 are straight.
Angle 1 and angle 2 are straight angles. Angle 1 and angle 2 are straight angles. Okay? So we can cross that out because we've already used it now. All right. The step 2 says the measure of angle 1 equals 180 degrees. The measure of angle 2 equals 180 degrees. Which one of those would go into that blank? Yeah. A straight angle is 180 degrees. So that's the definition of straight angles. Okay? Now it says measure of angle 1 equals measure of angle 2. Yes, sir?
Oh, I was going to say property of equality.
So it's substitution or transitive. Either I would accept either one. Okay? Because if they're both equal to 180, I could substitute M2 in for 180. I'm looking for transitive there anyway, so you can say transitive. Because if they're both equal to 180, they must both be equal to each other. Okay? So you could use substitution or transitive. And the last thing,
Wait,
guys,
is it property of
property of
equality?
equality.
Oh, that's what that sign is.
Sorry.
Okay. I was like,
Property
what
of
is that?
equality. Okay? Now look, I don't even have to think about the last one. What does it have to be?
One.
Angle 1 is congruent to angle 2. But how do I know that?
The definition of.
If the measures are equal, well, they must be congruent because that's the definition of congruent angles, right? Does that make sense? Good. Okay. All right, are we clear on this? Any questions about this? Okay, so let's continue marching forward. All right, number 7, and then we will have finished, and then you guys have your homework is the other side, B. Okay? Okay. Follow the plan to fill in the blanks in the two-column proof. So it's given angle 1 and angle 2 form a linear pair. Okay, so these two angles form a linear pair. And angle 3 and angle 4 form a linear pair. So these two angles form a linear pair. So that's what's given. It says prove angle 1 plus measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals 360 degrees. Okay, and the plan is, look, read the plan. The linear pair theorem shows that angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary, right? That's what the linear pair theorem says. Okay, the definition of supplementary says that they add up to 180 degrees, right? Well, use the addition of property of equality to make the conclusion. Well, if they're both linear pairs, they both add up to 180, right?
Yeah.
Well, what's 180 plus 180?
360.
That's the plan. So that's the plan. You see that? Okay? So the first statement is they both form linear pairs. What's the reason?
Given.
Given. The second statement is angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary. Well, how do I know that?
Transitive. No.
That's the linear pair theorem. The linear pair theorem says if two angles form a linear pair, then they're supplementary. You guys remember that? So that's, you'd put the linear pair theorem. Okay. Now, number 3, it says the reason is it's the definition of supplementary angles.
Angle 1 and 2 equal 180 and
Measure 1 plus measure 2 equals
180.
180. And what else do we know?
3 and 4 also equal 180.
Measure 3 and measure 4 add up to 180. Because that's the definition of supplementary angles. If they're supplementary, they add up to 180. Yes, sir?
So how'd you get linear pair theorem?
Because that's what the linear pair theorem says. If two angles form a linear pair, then they're supplementary. So that's what the reason is. Does that make sense? And you just have to know what the linear pair theorem is. That's one of the tools that we have in our toolbox. Okay? Well, now it says measure 1 plus measure 2 plus measure 3 plus measure 4 equals 360. Well, how do I know that? The addition. If they add up to 180, if I add the same thing to both sides, that's the addition property of equality. If I add them all up, that adds to 360. Does that make sense to you guys? Do you understand? Okay. Now, you're going to have this video that you can watch on YouTube. God willing, I hit start record, which I did. Thank you, Jesus. Okay, so you're going to have this video on YouTube. You'll also have all your videos that are available to you on my.hrw.com. Guys, hold on for a second. You have, tomorrow we're going to do our test review, okay? So listen to me, guys, stop backing up, please. Stop backing up. Tomorrow you guys have your test review, all right? So since you have your test review, what I recommend is that you review tonight so that when you're coming into the test review, you're like, okay, I know what the deal is. I'm not just refreshing for the first time in the test review. You're refreshing tonight, so you come in tomorrow already refreshed, and you can ask pointed questions. Mr. Meneer, I don't understand lesson 2.3. The test is on lesson 2.1 to 2.6. Okay, all of chapter 2 that we've done. All right? So I don't understand lesson 2.3. I look back at my worksheet and I just don't remember it. I don't understand it. And then you can ask questions. Oh, I don't understand this point. Right? That makes sense? So go back and refresh tonight, guys. Remember that I'm your teacher. Hold on a second. Remember that I'm your teacher, but I'm not, and I'm your coach, but I'm not your slave driver, right? So I'm not enslaving you guys to math. I simply want to teach you and help you to do well. So me as a teacher, it's like 50% teacher, 50% coach, right? Me as a teacher, hold on. Me as a teacher, I can teach you the lessons, I can provide you the homework, I can provide you the tests, and I can grade them. But me as a coach is coaching you guys, hold on, Olivia, 1 second. Me as a coach is telling you that you guys need to make sure you're going home and using the resources wisely. So you have to do your part, otherwise it's not going to work. So go and do your part. Fresh test is on Tuesday, tomorrow's test review. Thank you.